Welcome to myprojectbazaar.com. Now we are going to discuss about the project single image dehazing using CNN. Now we are going to discuss about the abstract of the process. One of the most interesting problem in recent times in image processing and computer vision is fog, haze and rain removal from the images. In this paper we shall consider the problem of haze removal. Here the latest haze removal algorithm proposed based on the dark channel prior approach for haze removal. We propose a process which is called the De-haze-Net for medium transmission estimation with DCP, that is the dark channel prior. De-haze-Net take a haze image as an input and then the output is medium transmission map, that is the subsequently used to recover a haze-free image via atmospheric scattering model. De-haze-Net based deep architecture layers are sequentially designed to extract the features from the hazy pixels, which can generate the almost all haze relevant features. We also proposed a non-linear activation functions in De-haze-Net called bilateral rectified linear unit, which is able to improve the quality of the recovered haze-free image. Hence, majorly we have considered the DCP and transmission map to remove the hazy pixels in the image. Hence, the output of this process will be the haze-free image. Then the quality of the image should be the increase. Finally, the performance, using their performance we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. At first, the modules of this flow is input image, pre-processing, haze detection, haze removal, dehazing the image, finally the performance estimation. At first, the input image is taken from the dataset. The dataset consists of the images having the hazy pixels. After getting the image from the dataset, we just move to the next step of the process, that is the pre-processing. In this pre-processing, we have two kinds of pre-processors is there. One is the image resize, then the another one is the data type conversion. So in this image resize, the image size of the image will be resized into an 256 cross 256. Whatever the input size, it will construct the image into one size of 256 cross 256, which means the number of row and column will be the 256. Then the data type conversion, in this the unsigned integer 8 into 1 converted into one double format. After the pre-processing, haze detection and haze removal will be carried out. These two steps will be the interlinked steps, hence the haze detection and removal are done parallelly by using these three steps, that is the dark channel prior, transmission map and contrast enhancement. Using these steps we can enhance the quality of the image. If the haze pixel is present in the image, means it will be detected in the haze detection step. Then the removal step is done by using the transmission and contrast enhancement method. After that, the output of this process will be the haze free image, that is the de-hazed image. The de-hazed image consists of without having any hazy pixels, and then the quality of the image will be retains the good. After the haze removal, the performance estimation is done by using the PSNR and MSE. PSNR is abbreviated as peak signal to noise ratio and MSE is abbreviated as mean square error. Now we are going to discuss about the running procedure of the process. First of all, open the Anaconda software Spider 3.7. After that, you have to change the current directory like this. Now you just go to the run button and click the run button. After clicking the run button, one tick enter will be open. In that tick enter, you have to select the image from the dataset. After the selection of the image from the dataset, the process will be done automatically. Now I will going to explain the process step by step. This is the input original image which I have taken from the dataset. After taking the image from the dataset, the corresponding result will be shown in the console. Then we go for the next step of the project, that is the pre-processing. In this pre-processing, we are doing the pre-processing like image resize. Here the image is resized into an aspect ratio of 300 cross 300, which means the number of row will be the 300, number of column will be the 300. After the image resize, the pre-process will be completed. Once the pre-process, the first stage of the pre-process is completed, then again we are enhancing the image by using the white balance equalization method. This white balance equalization method, the unwanted pixels will be removed during the white balance equalization. Hence, we are applying the white balance equalization. You can see the difference here. This is the original image which we have taken from the dataset. This is the white balanced image. You can see the difference. After that, the channel separation will be carried out. In this channel separation, basically the RGB channel, the color image having the three kinds of channel, that is the RGB, that is the red, green, blue. This is the image represents the red image. Then this is the image represents the green band image. Then finally this is the image represents the blue band image. After the color conversions, we are just going to apply the grayscale color conversion. Now the RGB image is directly converted into a grayscale image like this. Then histogram equalization. Now we are going to do the histogram equalization for separate three channels like red channel, green channel and blue channel. This is the result of histogram equalization for red channel. Then this is the result for histogram equalization of green channel. Then this is the result for histogram equalization of blue channel. Then this is the initial enhanced image. In this initial enhanced image, some of the fog regions will be eliminated and then the other fog regions will remain the same. That's why we are go for the final haze removal portions. In this haze removal portions, you can see the difference. Only the good quality pixels retains and then the another hazy pixels will be removed. You can see the difference between the original image and finally enhanced haze-free image. The performance of the process will be evaluated by means of the PSNR and the MSE, that means the peak signal to noise ratio and mean square error. You can see the values of PSNR and MSE here.
Thanks for watching this video.